Hi there, class. I'm trying this screencast for the first time, so bear with me if I make some mistakes. But today we're going to be looking at writing formulas from ions. So the basic idea here is that we have positive ion, meaning it's lost an electron, it's given that to some other atom, and that atom is now a negative ion. And because a positive ion and a negative ion attract, we get a bond, because a bond is an attraction of two atoms. And so today we're going to be looking at the formulas that we get from that. So for example, if we always start by writing the cation first and then the anion. Remember, cations are positive ions. Remember, because you have a positive feeling when you see cats play with metals. Metals form cations that are positive charges, and then anions are the negative charges. So you always write the positive charge first, which kind of makes sense because if you look at the periodic table, it goes from left to right. Sorry, I guess for you, from left to right. Or when you watch a video, do I do it the right way? Anyways, so the periodic table, if you look on the left side, has the metals and the cations, and so those come first, and then as you read across, you get to the anions second. So that's kind of a way of remembering that. So you always write the cation first. So for our example, we're going to do manganese, which has a +2 charge, and chloride ion, which has a -1 charge. So how do we know how many manganese ions it takes to pair up with how many chloride ions? That's the idea of the ionic formula. Okay, so what we're going to do is we're going to use the crossover method here to balance the charges. The crossover method basically says we take the 2 plus 2, and we're going to draw it, put the 2 down here by the chlorine, and we're going to take this -1 and put it down over here by the manganese. But do we write that there's one manganese? No, we never write that there's one manganese. So we just end up with MnCl2. Okay, so now why is that? Why does this magical crossover method work? Well, we got to make sure that we always end up with a neutral situation, because we never get a flood of electrons from somewhere else. So the electrons that would have, so to speak, started with manganese and chlorine have to have gone somewhere. We have to end up neutral. So if we have a manganese that has 2 less electrons, or you can think of it as given up 2 electrons, but it has 2 less electrons, and the chloride ion, each chloride ion has 1 extra, well, kinda, you might think of it as the 2 electrons from manganese, one of them went to one chlorine and one of them went to another chlorine. So each manganese will kind of produce 2 chloride ions. And so that's why we've got this situation. Or you can just look at it that one manganese has a +2. And so to balance out that +2, we have to have a -2. Well, if each chloride ion has a -1, then there must be 2 of them. Okay, so one manganese has a +2, 2 chlorides, each with a -1, gives us -2, giving us a neutral atom. Finally, if you were to get something with a 4 charge, like let's say you had lead +4 and oxygen -2, then those would not give you Pb2O4. You always want to simplify to the smallest whole number ratios of the ions. So it'd just be PbO2. Okay, because we aren't actually forming molecules, it's just the ratio of these things, and so you wouldn't have a ratio like 58 to 116, it would be 1 to 2. Thanks for listening. There's some more to practice on the next step in the pair deck, so go ahead and click forward and you can practice on those things.